Hi, let's talk about a favorite topic for adventure movies, the whole idea of quicksand being an incredibly dangerous object. So, the typical story, adventure hero guy has stepped into quicksand unexpectedly, seems to be sinking, and everyone decides, ooh, we need to rush in, yank him out of the quicksand fast before he dips below the surface. Well, is that really what would happen in the real world? From the tone of my voice, it should probably say no. Well, the whole idea with quicksand and what makes it potentially dangerous is quicksand is a type of non-Newtonian fluid called a thixotropic fluid. And a thixotropic fluid means that if you are essentially at rest, it behaves like a normal Newtonian fluid. However, if you try to move quickly through that thixotropic material, the viscosity plummets. And it's essentially like all of that water that is suspending the sand particles drains away, and the quicksand acts more like cement than like a liquid. Another example of a thixotropic material is if you mix up water and cornstarch in just the right amount, you'll get this little paste that would pour off a spoon, but if you give it a sharp tap, it'll crack just like a solid object. And there's some videos, there's some TV shows that have been done showing folks running across giant vats of cornstarch and water. It's kind of a mess to try it at home, so you probably don't want to do that. So, if we really want to talk about floating, we need to consider densities. So if the density of an object is greater than the density of a fluid, it sinks. Well, our object is a person, and the density of a person is about 95% of the density of water, because people float in water. Quicksand is typically dense soil particles, sand particles, mixed into water. So it's going to have a density greater than the density of water. So let's say that the quicksand we're dealing with has a density of about 1.6 times the density of water. That's more than the density of the person, so the person's going to float. How much in terms of floating? Well, the buoyant force is going to be the density of quicksand times the volume of quicksand that's displaced times the strength of gravity. Well, that has to support the weight of our person, which is going to be the density of our person times the volume of our person times the strength of gravity. So the volume of quicksand that we'd need would be the ratio of the density of the person to the density of our quicksand times the volume of our person. So the volume of quicksand that we displace is going to be 0.95 divided by 1.6 times the volume of the person. That gives us about 0.59. So 59% of the person sinks in the quicksand, the other 41%. So basically from about here up, as long as you stand still, would be poking out of the quicksand. Now, about the worst thing you could do to your adventure friend is throw him a rope or a lasso or a snake, hook it up to the back of a Jeep, and try and drive away. Because that would be about like trying to rip someone out of dried concrete, and it's not going to go well for them. Thanks for watching.